in controls is this that covering the Heaviside step function. And again, what is the Heaviside step functions? Basically, this one indicating is this. This is the if we have this is a value of 1. This is time. So here we have 8. So that means the unit step functions is fired up at t equal to a, not 0. Okay. So for example, if we have the general step functions, and so say this is a step functions, and I would say the unit step function is like this, starting from 0. Okay. Usually, in terms of the many textbook, the unit step function is simply using UT, means unit step functions. If this unit step functions is starting at here, so say if t equal to 5 seconds, then this function can be described by either per our notation h t minus 5, and in certain textbook and also most of the time in papers, they also can be described using u. Okay, and t minus 5. I think using the symbol u is more common than h. But either way, that's kind of the generic terms here. Okay. Okay. Now, with this notation that defined, then we can see their Laplace transform, inverse Laplace transform. For this, we know for a constant 1, and after Laplace transform is 1 over s. Okay, so this basically this is the step functions. Okay, so that function is like this. And now for this one. So this is a and this is t. This value equal to 1. So for this function, then you use this one t minus a. Okay? T minus a under these situations, then we can have this one is basically this is multiplied with 1. So this one is e minus as. Okay? And if this function multiply with, sorry, my mistake here. Let me correct my statement. Because this one, the only step function, delayed fire step function that multiply with 1. So you cover this 1 after the Laplace transform is 1 over s, as they described above here. Because of the delayed firing up of the step function, it corresponding is pre-multiply that function with this one. Okay, that is a way to interpret the result. And so for example here, so say we can exercise another one. So say for t, we have the step, the corresponding, the Laplace transform is this. Okay, so now if we say u t minus 1 times t, okay, so if we have this function, what that means, this function is this. The first one, this is t. This is the let me say f of t. So the f of t equal to t. So that is this function, the slope equal to 1, this is time. Okay, so this function, that means here we have the multiplication with the unit step functions. So that means eventually is this. Okay, so hopefully you can see the difference. So for the red one representing is this function. This function basically is inactivated between 0 and 1. It's going to be activated when 1 arrives. So that means it suddenly jumps to the value here, which is equal to 1. Can you see the difference? Okay. So now for this one, we want to utilize these equations. Then we can do is this. Again, we want to arrange into this form. So this is the t function of t minus a. This is the f function of t minus a. So you have to do it. So that means here you have to convert it u t minus 1 and multiply. This is the function. You have to become t minus 1 and plus 1. Okay? Because this t equal to t minus 1 plus 1, and we put this form because we want to fit into the tables here. Okay, so basically we split into two forms, t minus 1 and times t minus 1 plus ut minus 1 times 1. Okay, two forms. And so for this one, the first term, we can utilize that equation there. And this equation simply taking is this. We added up this delayed, and then we're looking into what is the transform generic of ft, that is f of s here. Okay, so f of s is the transformed with respect to the f of t. And now with the delayed firing, so we simply multiply with this. So again, for this case, we know this is the template originated from t, right? So its Laplace transform is 1 over s squared. With delayed, so that is minus t here. A bit good? Okay, and now again, for this one that corresponding Laplace transform has 1 over s because of the delayed, and that is minus t here. So that is the answer. Okay. For these questions, if you doing this t minus 1 times t, if you're going to do the Laplace transform of this by doing this, you simply looking up, oh, t is the Laplace transform is 1 over s squared, and then this is minus 1, we know, then we simply minus, multiply with e to the minus s. No, this is not correct. Can you see the difference between the wrong solution and right solution? Again, the formula will be working. The key is this one. You need to make up this one. This is a function of t minus a. So, but this is a function of t, not of t minus a. So that is the error, the source of the error. Okay, students before commonly make mistake, in particular in applying this shifting theory. So here I kind of highlight to you. Okay. If you don't believe it, then the simplest way is to simply plug in whatever the function into the original definition of the Laplace transform. The Laplace transform is this. Any functions, and that one simply defined is f of t e minus a t d e s t d t from 0 to infinity. You simply plug into this fundamental definition and then do the very hard, not very hard, just do the integral and you will get the answer as well. Okay. Any questions about this? Good. Then the next page, convolutional integral, and this one providing us a different method. Sometimes will be a little bit convenient.